Hi, my name is Jay Anderson. I'm a PhD candidate at TU Delft in the Netherlands, and I'm very happy to talk about this work developed with our industry partner. So to provide you a bit of context, Adyen is a Dutch company that connects merchants and shoppers all around the world. And at the core of the business, there is a payment platform in active development. In this context, application logs are key to monitor release changes and to provide the data for analysis. However, this process is not always straightforward because whenever something is missing, the developer needs to submit the required changes and wait for them to go through the entire process until the data reaches a satisfactory state. In fact, this is not an unlikely thing to happen, and previous studies in open source projects also report a similar pattern. So achieving consistent logging is hard. And while more experienced developers are able to anticipate potential issues during code reviews, this approach does not scale at company level. So in an ideal setting, we would be able to capture every log-related issue before deployment. So with this challenge in mind, we studied whether we could train a model for this task in an enterprise system. And to do so, we defined a simple approach based entirely on code metrics because they're simple to compute and haven't been fully explored on related work. And we also framed this problem as a binary classification task. And the rationale for that is that there aren't many log statements when a method is logged, as you can see in the violin plot on your right. And also we can trade the benefit of using more complex models over simple models. So we evaluate our approach under 4 different perspectives. First, we check whether it's feasible to use code metrics as predictors. And as you can see in the results, our best performing model achieved good results and gave us confidence to explore whether we could improve performance. For that, we explored different sampling techniques during model training. And what we observed compared to the previous results is that sampling improves recall, but at a prohibitive cost in precision. That means that a recommendation tool based in those models would produce a lot of false alarms and wouldn't be useful in practice. So we were also curious about what the models learn after training, since we are using different models in pre-processing steps. Here we analyzed feature importance across models to check whether they capture different characteristics from the dataset. And the results show they show a mix of structural properties, such as number of method invocations, and metrics related to code complexity, such as coupling between objects. But the number of nested blocks was the most perceived feature, and it might be useful if you're building a model for a log placement. Finally, we explored whether we can train whether we can train a model based in open source data in case there is no training data available. And for that, we used data from Apache projects. So in one experiment, we combined all data sets together as a single training set. And in another experiment, we trained the models based on the individual projects. So here I'm highlighting just the main results of this experiment. And as you can see here, the model based on CloudStack achieved the best balance between precision and recall. But when you combine all the data, you have a model with a comparable number of false alarms. So the main takeaway here is that you can leverage open source data in case you don't have any data available for that. So I hope that I sparked some curiosity about our study. And if so, I invite you to check our paper and get in touch. I would love to know what your thoughts about it. So thank you for your time.